Welcome students. Today's session discuss inner transition elements. So lanthanides and actinides, F block elements will be considered, and lanthanides is a 14 elements present, cerium to lutetium. From the will be started for D block elements for lanthanum, and the F block element started for cerium. Is the next 4f orbitals. Outermost cells is the perforational filling is 4f orbitals, and actinide is 14 elements, thorium to lawrencium. So following the actinum, the characteristic filling of 5f orbitals. The periodic table, group number 3 to group period number 6 will be started. 6th period, lanthanum to 4f subcell, 14 elements. So electronic configuration, xenon 4f 1 to 14, 5 to 0 to 1, and 6s to outermost. Common oxidation state plus 3, and the properties is will be separated positions of the every element. So will be arrangement of F block elements for lanthanums. So and next will be considered is the third group number. 6th period will be lanthanum will be start, and 7th period is the actinium will be started. So already known for the electronic configuration. Next depth discuss cerium to lutetium, electronic configuration of outermost cell and oxidation properties will be discussed. So outermost cell, first lanthanum and cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, and ytterbium and lutetium. So important: lanthanum, cerium, erbium, gadolinium, ytterbium and lutetium. Outermost configuration is very important for that elements. So gadolinium and lutetium. So gadolinium is off field and lutetium. What is the off field? 4f7, 5d1, 6s2. So 3 electrons will be lost. 4f7 is a gadolinium. 4f7 is 3 electrons lost off field of the outermost cell. And lutetium cell, 4f14, 3 electrons lost, 5d1, lutetium 5d1, 6s2, 3 electrons lost. For outermost configuration 4f14 is a completely filled, is a more stable. So lanthanide is a common oxidation state plus 3, and the lanthanide is the plus 2 or plus 4, plus 3 plus 4 oxidation state. And next will be similar compared to the cerium and terbium. 4 plus electrons lost, outermost subcell 4 electrons lost, cerium 4f1, 5d1, 6s2. So loss of 4 electrons is the empty. And next will be the terbium. Terbium is the 4f9, 5d0, 6s2, 4 electrons loss, 6s2 loss, and 4f7 configuration is a off field. So cerium is a empty, outermost subcell of 4f0, terbium is a 4f7. So more stable. And compared to that, very important question, lanthanide contraction. So lanthanide contraction, atomic number are lanthanide shows the gradually decreases and increases atomic number. The atomic number increases, decreases the ionic size is called lanthanide contraction. Is a very important 2 mark questions. And the discuss depth for lanthanide contraction, that series will be referred. And next is basicity, important question, cerium to lutetium. So lutetium. So character of lanthanum is a ions is a decreases of basicity character. So what is the size variable? Is the lanthanum hydroxide is the bond decreases. So increases of respect to the decreases of basicity. Cerium to lutetium. So very important question. Next, similarity of lanthanides is every series 3D series variation radius 10 parameter decreases. Another compared to the 4D series 20 parameter for the next series decreases. Is the outermost configuration discuss. Compared to the 3D series titanium and the 4D series zirconium and 5D series hafnium. So 132 parameter and 144 compared to the 20 parameters is the variable. So next discuss for actinide series. So already discussed from thorium to lawrencium. So important. So all actinides are the short half-life period except thorium, uranium. The starting of the thorium and uranium is the recurred to the trace amounts is the plutonium found of the uranium ores and neptunium. So importance of the synthetically prepared the importance for nuclear reactions and electronic configuration similar of the lanthanide properties. So this is the 4F for lanthanides. This is actinide for 5F 6D 7S 5F 2 to 14 6D 0 2 to 7S. So important configuration actinium, thorium, uranium, and next you will be consider californium, and last einsteinium is the important outermost electronic configuration, nobelium and lawrencium. So compared to the lanthanide to actinides, so actinides is the common oxidation state +3 no problem, but variable oxidation state +2 2 and +7 higher oxidation state is the amazium. Is a very important 1 mark question. Amazium is a +7 oxidation state, and lower oxidation state no problem, +2 oxidation state, but the 1 mark question will be asked the question very important. Amazium is a +7 oxidation state, neptunium, plutonium is a +7 oxidation state. Next that element amazium, thorium is the +2 oxidation state, some compound easily formed, thorium iodide, and that important questions will be that part indirect questions will be asked. That element thorium, palladium, uranium, neptunium, plutonium, americium shows the +5 oxidation state, and neptunium and plutonium exhibit plutonium is a +7 oxidation state important. And differentiate between lanthanide and actinide important question. So outermost subcell enter of the electrons is the 4F orbitals, and compared to the different to the enters of electrons 5F orbitals, and binding of the energy is 4F orbitals, and next will be the binding of energy lower or 5F orbitals. The 4F orbital energy is higher, this energy is lower, and tendency is of the less tendency of lanthanides and greater tendency of the complex formations. The lanthanides are most of ions is the colorless. So actinides of the form the complexes is the actinides is colored, uranium 3 plus red, uranium 4 plus green, uranium oxides is the 2 electrons lost, dioxide is the yellow colorish. And next will be that they do not from the oxocation, they form the oxocations. So this is the form is the oxide cations. So oxocations easily react for actinides, lanthanides do not react for the oxides. So uranium dioxide and neptunium dioxide for that form of the oxocations. So compared to the oxidation state, common +3 oxidation state, +3 oxidation state. So here the oxidation state already discussed +2, +3, +4, and the oxidation state of such as +4 to common such as higher oxidation state +4 to +7 is the possible. So very important 2 mark 3 mark questions for differentiate for lanthanide actinide questions. Differentiate another lanthanide contraction, very important question. Another one characteristic for the lanthanum hydroxide basicity character, very important, and how will be present of the F block elements in the periodic tables. Indirect questions is also most asked. And last only possibles for outermost electronic configuration, some important elements, lanthanides and actinides, and the elements that lessons also finished 4F and D for D block elements. So inner and transition elements and inner transition elements, most of hints also given. So very important for 4th lesson. Next we are well prepared and 4, 5, 6 for the upcoming public examination. Very important lesson 4, 5, 6 and very important for 4, 5, 6 lessons. So next will be the lesson will be gathered through the first lesson will be discussed. Thank you to all.